Hi everyone, welcome to week 3 of our distance learning pre-algebra. We are going to talk about line and angle relationships and special names that go with them, as well as triangles and special names for triangles. All right, remember, parallel lines are lines that never intersect. Okay, so what we've got these symbols here, those symbols mean that these two lines are parallel. Whereas that blue line there, that's called a transversal. So I'll actually highlight that in blue, the best blue color I have here. So that is called your transversal right here. I'll put a T for transversal. It's a line that intersects two or more lines. Corresponding angles are two congruent angles that have the same position on the same side of the transversal. And that symbol that I wrote there, that's congruent. Okay, that's the congruent symbol, just as a little bit of a reminder for us. So congruent means that they're the same measurement. So my parallel lines are A is parallel to B, and the transversal is T in this case, in this picture. Name 4 pairs of corresponding angles. So you can see how I have clusters of angles here. I have like this top cluster and this bottom cluster. So when we say the same position, we're actually talking about like upper left. Upper left would be angle 1. Angle 1 is in the same position upper left of angle 2. So angle 1 and angle 2 would be considered corresponding angles. And then upper right, 3 and 4 would be corresponding angles. And then to pick another color, bottom left, that would be 5 and 6. 5 and 6 would be called corresponding angles. And then our last pair, bottom right and bottom right, that's 7 and 8. 7 and 8 would also be corresponding because they're in the same position. Then we're going to talk about these words interior and exterior. So what they mean is that if I make like a little bit of a house here, pick this color, okay, I'm going to make a house. So notice how I've kind of made a house here. So you've got an interior part of your house. So the inside of your house. So we're really talking about the angles 5, 7 and 2, 4 when we're talking about alternate interior angles. So these are two, once again, congruent angles. So I'll write that symbol and write congruent. So meaning they have the same measurement, that are inside the parallel lines and on opposite or alternate sides of the transversal. So if I look here, that would be like 5 and 4. Okay, angle 5 and angle 4 are on the inside of the parallel lines. Okay, they're on the inside, but they're on opposite sides of the transversal. One's on the left side of this line, one's on the right side of that T line. And then the other side would be, or the other pair would be angle 2 and angle 7. Okay, those are also alternate interior angles. And then you have the alternate exterior angles. So once you go back to the house, your exterior are ones on the outside of that house. That would be an exterior, and that would be an exterior. So we're really talking about angles 1 and 3 and 6 and 8. So those would be our exterior angles. Okay, so these are two alternate interior angles, or two congruent angles that are outside, hence the word exterior, of the parallel lines on opposite sides of the transversal. Okay, so a pair would be like 1 and 8. Okay, 1 and 8 are both on the outside and they're on opposite sides of that T line. And another pair would be like 3 and 6. Angle 3 and angle 6. Adjacent angles. So these are two angles with a common endpoint, or vertex. Actually, let's go with the word vertex. A common vertex and a common side that do not overlap. So basically they have to be shoulder to shoulder from each other. So we have an example here where they're shoulder to shoulder. And we have a separate example right here where they're shoulder to shoulder. Okay, so those are our two examples. All right, tell whether the angles are corresponding. So I'll write CORR for corresponding. Alternate interior. So I'll do AI, and you guys can abbreviate too as you're going through. Alternate exterior, vertical, which remembers you're making those two V's, or adjacent, ADJ. So we'll use some abbreviations. If you want to use C, V, and A, that's fine. I'm okay with using one letter for those. So 2 and 3. So first of all, I'm going to make the house. Okay, the house is going to tell me, because I'll have interior angles there inside of the house. So these would be considered your interior angles. And then you've got your exterior up at the top. So that would be 1 and 2, and your exterior down at the bottom. So if I'm looking at angles 2 and 3, angles 2 and 3. So 2 and 3 are opposites of each other, and they actually create these V's. So they cross each other and they make these V symbols. So when you make the V's, those are your vertical angles. Next pair would be 4 and 5. So angle 4 and angle 5. Notice how they're both in the interior part of our lines, and they're opposite of each other. So that would make them alternate interior angles. So AI. All right, I'll erase that and go back. We've got 1 and 8. Notice how 1 and 8 are both on the exterior part. That would make them alternate exterior angles. Okay, alternate exterior angles. So I'll do AE. And then we've got 2 and 6. So 2 is in the top right. 6 is also in the top right on the bottom part of that cluster. So if you're in the top right and the top right, it looks like they're in the same position. So if they're in the same position, that would be corresponding. So I'll write CORR for corresponding. Then I've got 3 and 7. So 3 is here and 7 is here. It looks like they're in the same position. Bottom left, bottom left. So I have another pair of corresponding angles. 3 and 6. 3 and 6 looks like they're both on the interior part again. So they're both interior angles and on opposite sides of my transversal. So they're going to be alternate interior angles. Okay, 5 and 8. So 5 is right here and 8 is opposite of it. You can see how we make those V's again. So those are going to be our vertical angles. 1 and 2. So 1 is here and 2 is here. So they're both exterior, yes, but they're not on like the opposite exterior. So they're not making the loops. They're actually right next to each other, shoulder to shoulder. So if they're right next to each other, shoulder to shoulder, this is our first example of adjacent angles. So those are adjacent to each other. 1 and 4. 1 and 4 are back to back to each other, making those V shapes. See how we have those two V's? That would be another pair of vertical angles. 4 and 8. 4 and 8, I've got one on the inside and one on the outside, which means they can't be the alternate interior, alternate exterior, but they're in the same position. They're in the bottom right of the clusters. So if they're in the same position, they're corresponding. 4 and 8 we did, so 6 and 7. 6 and 7 make those V's again, so those are going to be vertical angles. And our last are 6 and 8. So 6 and 8 are right next to each other, shoulder to shoulder, so they share that shoulder right there. That would make them next to each other, so they are adjacent. All right, find the measures of the angled of the numbered angles at the bottom. So if I'm looking here, I'm going to fill out this bottom cluster first, and then you can pick it up and it's going to be the same measurements up at the top. That's the nice part about the clusters. Whatever's at the bottom is going to be the same thing at the top. So if this is 75 here, vertical to it, angle 6 is also going to be 75, which means if I'm picking these up and moving it over, this is going to be 75 and this is going to be 75. And then notice how these two angles here, they form a straight line. So a straight line means they have to add up to 180. Okay, they are supplementary angles. So if I take 180 and I subtract 75, it gives me 105 degrees. So this angle is going to be 105, and this angle, and this angle, and this angle. So you'll notice you can kind of pick up and move all of the angles from the top and the bottom, and they're all going to match up. So looking over here at 14, if this angle here is 125, this angle is also 125, which means this angle is going to be 125 because they're in the same position, and 3 and 6 are going to be 125 because they're in the same position. And to figure out my other angles, I've got a straight line here that's made up of these two angles. So if I do 180 minus 125, that's going to give me what, 55? Right, 55, 6, 7, yep, 55 degrees. So this angle is going to be 55, and this angle is going to be 55, and this angle, and this angle. Okay? And notice, some of you guys might remember that all the angles here, a whole circle has to add up to 360, so you can check yourself by adding up all 4 of those angles. It should add up to 360. All right, our triangle notes. So just like before, I'm going to show you all the definitions. I want you to pause it and then record the definitions down. All right, so here are the definitions. Take a moment to pause the video and copy these down. So an acute triangle is a triangle with 3 acute angles. So you can see there all of my angles are less than 90. I've got an 85, a 35, and a 60. A right triangle is a triangle with 1 right angle, so 190 degree. An obtuse triangle is a triangle with 1 obtuse angle, so 1's going to be greater than 90. And an equal angular, keyword here, angular, triangle has all the angles the same, and they're all going to be 60 degrees. And a triangle should always add up to 180 degrees. Okay, here are our sides. So take a moment, pause the video, and copy down these definitions. A scalene triangle is a triangle with no congruent sides, so they're all the different side measures, 10, 2, and 5. Isosceles is a triangle with 2 congruent side measures, so you see that those congruent marks there, 3 and 3, are equal to each other, where 4 is different. And an equilateral triangle is a triangle where all the sides, all 3 sides, are going to be equal to each other, and you can see in my picture that they're all equal to 5. All right, there are some special cases. A triangle is equilateral if and only if it's equal angular. So basically that means that if you're going to write that a triangle is equilateral, it's the same thing as equal angular. So if it's equilateral, which meaning all the sides are equal, which is what I've got here, all the sides are equal, it's the same thing as saying you have an equal angular triangle. And then another special case is that if you have an equiangular triangle, meaning or equilateral triangle, meaning that all the sides are the same, you can actually also call it isosceles. Okay, so that's just a little extra for you. All right, we're going to classify based on angles. So angles would be the right, acute, obtuse, equiangular. So right away, I see that right angle, so I'm going to call this a right triangle. I see this angle here, it definitely looks more than 90 because 90 would be more like that. So that would be an obtuse triangle. And then all of these angles look pretty much the same. I would hope that they would all have little angle measurements, but we would call that equiangular. Okay, meaning all the angles are the same. And then classifying it based on sides. So it looks like no sides are equal to each other because I don't have any of these congruency marks here on that triangle for number 4. So you would call this a scalene triangle where I have all of the sides equal. So we would call this an equilateral triangle. Let me go back and check. Yeah, that's what I thought. There's my equilateral triangle because all 3 of them are equal to each other, and this would be isosceles. And like I said before, if it's equilateral, it's actually also can be called isosceles. That's just a little bit of an extra thing you can throw in there. All right, finding the missing angle measures. Well, you add up the 2 that you know and you subtract them from 180. So 43 and 60 is 103. Subtract that from 180. It gives me 77 degrees for x. And then if I add up 40 and 30, it gives me 7, so I get 110 degrees for x. All right, move on to the second video.